every day she says it to me. And this is something that you will hear from your students. And we will talk about that specifically. But this doesn't have to do with motivation. This is part of who they are. So challenges forming relationships. Sometimes you will feel this from them. That's okay. It takes time. You will hear lots of things about not being able to focus. You will hear things about anxiety. They will talk to you about these things. They will talk to you about physical symptoms they may have. They may feel actually physically sick while they are with you. That would be normal, right? This is not a made-up thing. This is a real documented fact about people who experience these feelings. What can you do? I do say this because I think this is a big one. Sometimes we forget yet.
Are you sharing your screen?
Oh no, I'm sorry. I'm so sorry. Thank you.
Click on Zoom at the bottom. Yeah.
Yes. I forgot about that. Thank you for saying that. Sorry, you guys at home.
There we go. Okay. Sorry.
No, don't be sorry. I'm so glad you said that. They could hear me, but they couldn't see me. Thank you for reminding me.
Well, they could see you. They couldn't see your screen.
Okay, well, that's okay. We can send you that later. Anyways, so on to Nancy, what can you do? So first,
It's all working now.
How to convey them to your students. I think we all know this, but it's just good to put in the fore. You will be feeling frustrated, especially if someone's not doing well. Think about it. Think about how you're talking about it. Routines, sharing what you're doing, review, because remember, cognitively, they may not be with you the whole time that you're going through things. So seeing it 2 or 3 or 4 times is going to be important. Be clear about, transparent about changes. If you're going to go on vacation, if something's going to change, you want to make sure you tell them way in advance and then remind them again and again, right? And explain why you're doing it. Transparency is a key for their safety. Notice if your students getting stressed, we'll talk about this again. You need to modify your work. You need to modify the pace. That's okay. It really doesn't matter. Their safety and their emotional sort of state of mind, you can't actually push through that to learn. So you just have to really keep it right there. Flexibility, keeping your student in the planning process, listening to their personal life. You can do that. And then celebrate, a lot of celebration of successes. Okay, so the big thing here, the big takeaway, remember we start big, go small, is that a lot of what you'll be doing is just acknowledging you're not here to judge, you're not here to fix, you're not here to do any of these things. You're just here to say, I hear that that is hard for you, and I'm sorry. Right? It's going to come up. So that's it for that trauma-informed care. There's articles and that you can get if you want later. Next is growth mindset. Growth mindset is huge in education right now. This is going to be more of a tool-based thing for you guys, which is good. So this is such a good summation of growth mindset. It's not that I'm so smart, it's just that I stay with problem solver. This is like growth mindset to the core. Okay, here we go. So I'm going to we're going to look at this, and I'm just going to say 30 years ago, Carol Dweck came up with growth mindset. I can hand this out for you, and you can send it to the people if you want. This is so research-based. It has done so much for people, those students and teachers, just recognizing this. This is intertwined with trauma, but they don't talk about trauma at all when they discuss it. But here, basically, fixed mindset, you're born with the ability to do math. Growth mindset, you do work and you're going to get better at math. Okay, so you can look at that later. That's sort of a summation of growth mindset. Again, I will send a 10 talk later. So much information about this. I can send you some videos too. So key points. Intelligence not fixed, it can be developed. Struggle grows your brain. So that part where your students are feeling uncomfortable, it's nice to have these things handy because they are going to feel very uncomfortable. they are going to have to struggle. And at that point, that is when their brain is growing. So the more information we can give them about that, the easier it is for them to work through that part of struggling and not just take off. Like students take off a lot. The brain is malleable. Plastic is the other word. It grows. We know this. The most important thing success comes from effort. Mindsets exist on a spectrum. You're not all fixed. You're not all growth. And you have multiple mindsets, meaning different things are, you'll have different mindsets for different things, right? Your mindset for writing is not going to be the same for your mindset for writing. Okay, so to teach your students must feel you believe they can reach their goal. That means you yourself have to have a growth mindset, right? You have to believe that intelligence is something that happens through work and not something that your student has or has not. To learn, a student must be able to persevere through mistakes and receive the feedback. We've heard that before, so that's how learning works. Maximize, you talk about effort, you talk about brain growth, and you talk about you and your student, what they overcome through hard work. That's the key to growth mindset. Minimize, talk about results, about smartness, what comes naturally, about easy successes. Easy successes are not what you're going to be dealing with, and probably not the thing that you're going to want to talk about. It's not what you're really good at, it's what you need to work at. This is the big word, yeah, you can add it to anything. If that's anything else you get from growth mindset, just add the word yet. Your student says, I cannot do math, you can't do math yet, I can't do algebra, I can't do algebra yet, I don't know how to, I don't understand ratios, you don't understand ratios yet. That's it. That's how you change the way you're thinking, so they are talking to them, so they know that you know and that they know. It's just a matter of time and work. Okay. I do have, again, an article for growth mindset that you'll get later. So these are the growth mindset things that you'll receive. This is an article. Research says if you share this with your student, their outcomes will improve just by reading with them. That's all you have to do. Here's a list of things you can say to your student to promote mindset in each circumstance. Here are 5 ways to promote growth mindset. Very easy things. Okay, so now we're going to be talking about focus, mathematical thinking leads to mathematical proficiency. What is mathematical thinking? So here's a quote that I love. Mathematics is not about numbers, equations, computations, or algorithms. That's what we think about when we think about math. It's really about understanding. How do you apply it? Where do you use it in your work? How do you use it for cooking? How do you use it in life? So broad mathematical thinking is exploring, questioning, working systematically, visualizing, conjecturing, explaining, generalizing, justifying, proving, all the heart of mathematics, right? So a larger part of your brain, a larger part of your world and thinking than just, do I get the answer right? You got to walk away from that a little bit. So fluency is what most people focus on, but it's a whole spectrum of things that we're teaching there. So questioning, this is how you get to mathematical thinking. Broad. Instead of just showing students what to do, teachers can employ pressing strategies that allow students to become active participants in the solving process. When this shift is made, not only are students more highly engaged as they're being asked questions about the solving process, but also develop a deeper understanding of concepts as they work to justify mathematical steps. So we know that when students struggle, it's not a lack of cognitive ability, it's a lack of understanding. They don't understand why they're doing their steps. They will not remember. The steps have no place to go. They're not connecting with the framework that you have in your brain. Knowledge has to be attached to things you already know, and steps just aren't attached to anything. They're not attached to understanding. So questioning is a way to build an understanding of what's happening. So solidify this every so often. You establish some trust in mathematical success to set the foundation. You can't really do this the first day, right? This won't work. A lot of failure in a mathematical classroom when you start opening the questions is because you don't have the foundations in your classroom to do it, right? So you want to build that trust, and then you're going to pose an open-ended question. What's an open-ended question? An open-ended question is something that doesn't have a right answer, one answer, sorry, not a right answer. It doesn't only have one answer, or doesn't have one pathway to one answer, right? Either one works. There's more than one way to do it, or there's more than one answer to that problem. So it can be as easy as, what's 2 plus 2? Well, 2 plus 2 is 4, one answer, right? How about, can you show me 3 different ways to do 2 plus 2? There's a million, endless, infinite answers to that question. Don't give instructions. You're not going to give 1, 2, 3 how to do this. You're going to guide through questions. We'll talk about that later. Or you're going to work together through modeling thinking. You know that this is where we think about the trauma from before. You can see that your student is traumatized because, or scared or fearful because you just pose an open-ended question and they don't know what to do. That's okay. You don't need to stop. You just do it yourself, but you do so by thinking about your process. You're going to ask yourself the questions and you're going to answer them in front of them. Right? You can do that. And they don't have to be, this is what I'm going to do, 1, 2, 3, 4. It's going to be, what do I see here? And we'll talk about those questions later. And then lastly, don't worry about the right answer. Have fun, talk to your students, be open to what they're saying to you. Be open to things that they can teach you in this moment. I have learned so much math from my students because there's just infinite ways to think about math and to do math and to draw pictures about math. And you need to find their sense making. That's how they learn. They don't need to understand your sense making. So what does this look like? These are going to be 2 most common questions you're going to hear, right? You're open-ended question. That's the first thing right here. How do I do this? And what are they going to want from you? What do you want to do? First you do this, then you do this, then you do this, and do this. Well, you've done all that thinking for them. That's not going to work every time. You can't take the test with them. So some questions to ask. What is the question asked? Have them tell you. Do you think the answer is going to be bigger or smaller? Very simple question. It's so amazing what that one thing can do for students. Am I going up or am I going down? Have you seen this question? Have you seen a question like this before? This looks like me. What does this question remind you of? Is this something that reminds you of work? Does it remind you of something that your kid brought home? Where can you find meaning in something that's happened outside of this space? Do you see any patterns? A lot of times you see a graph or a table, or if some of these open questions will be very visual. Can you draw pictures? Lots of word problems lend itself to that. What would be a good guess? So all of these things are good starting questions. And then, is this correct? I encourage you, even if you don't do this for opening questions, for every question to ask, how would you know if it was correct? How would you know? Can you check it? Even things to calculate. That's one step to them empowering and taking confidence over their own mathematical experience. Does it seem reasonable given the problem? I rarely give an answer without asking that question. Does it seem reasonable to you? If I'm subtracting and that number is bigger, is that reasonable? You will be given types of mathematical questions and circumstances in which they will come up. You'll be given a very long article about questions. First thing again is probably the thing that I spent the most time with in my $100,000 mathematical education. This is what they teach. Even if you just do it a little bit, it will help. Okay. We're done with questions. Oh, wait, we're not. Oh, we're not. This is an open-ended question. So So we'll just think about one to show you one. These are my favorite ones, hands down. So again, if nothing else, you can just go through it. Okay, which one does not belong? So these are both things all in one. There's more than one answer. There's a million ways to do it. You're just talking. It has nothing to do with math. There's no numbers. Look here. Which shape doesn't belong? Could it be this one? Because it has a parallel? Could it be this one? Because it says more than 4 sides? Is there other ones? Who knows? Your students will tell you things that you never thought of. And it takes 5-10 minutes. And it will really impact, really grow mathematical thinking. It takes 5 minutes. This is such a great research. You will see this in a minute. So there is a list of other ones. These are a little bit more, the more you get into, these are called rich hacks, is another term to say them. There's a whole bunch of these. You really have to dig. These ones are super easy. These are a little bit harder. There's so many different things you do. You could just bring in a bunch of stuff and just have to categorize it. There's just a million ways to do this, but if you're just getting your toe in the water, easiest way to do it. And then the opening questions you will receive. So you can just even have them sitting in front of you. Okay. Multiple representations. Are you guys good with the question? Any questions about the question? Okay. Okay. Multiple representations. So multiple representations, what that just means, it's pretty, this again, oh, I love this book. Sorry, it's really up close. Mathematics has beauty and romance. It's not a boring place to be in the mathematical world. It's an extraordinary place. It's worth spending time in. Math is everywhere. It's beautiful. There's a joke on it this little bit. So if you think about all biology is chemistry, right? All chemistry is physics. All physics, not really joke, is math, right? Really, essentially, it's the underlying process to the world, looking at the world. And that's not true for everybody, but it exists underpinnings of those things. Fibonacci sequence. Anyways, I try not to know that one. Okay. So this is did you say too late? Okay, sorry. I'm so okay. So and whatever. Okay, so this again, this subject's so large. Like I have tell a story for the first one. You could tell a story in mathematics and get a million different research papers on this, right? So I'm not going to go too deep into this one because it's just something that it'll come naturally over time. So I'll just tell you a story when I was in class. So like when I was young, my mom was at home, and you know those things in the 80s was those Tony's pizzas. They still exist, right? They had about 10 of those in the freezer all the time. So my brother and I would share a Tony's pizza, right? My favorite mistake for us now, but we were kids. And then he would take half and he would roll it up and eat it like pizza. I don't know. I don't know. And then I would take my half and I'd cut it up into 3 or 4 pieces, right? We eat a different amount of pizza. Well, we ate a different amount of pieces of pizza. And that would accompany a picture of a pizza. And then I've just described what an equivalent part is. We all have stories. Okay, draw a picture. You guys got that one. You can find one of the graph, online resources, manipulatives. I'm guessing you don't have these at home, but if you want them, if you could, they're online, right? Fake money. I love these things, but really, honestly, I love geometry, the things for this, but honestly, we all just have a tissue box at home, right? Give your student tissue box, have them take it apart, right? just simple as that. Have a look at the tissue box, have them, do take a ruler and measure all the sides of the tissue box. They're gonna understand surface area and volume like they never have before, right? We will look, obviously this one's pretty straightforward, but really hits a lot of marks. What are you interested, what is your student interested in? Cooking, lots of math and cooking, sports, all these things have math. Find it. Sure, and then it says there's math and thing, but I think you already got that, I think that. Okay. So 2 examples. My students in my morning class having a hard time with pints, gallons, cups, right? So measuring cups and some beads, just bring them in and let them play with that for a while, right? It doesn't need to be complex. You don't even really need to have a gotcha at the end, right? I think you think that we're wasting our time if they're not doing math on a piece of paper. We're really not. That engagement with their brain is so large to see how many beans fit in a cup, how many beans fit in a quart. Just looking at it, and then you can show them measurement on the side. Okay, this is where we get. Okay. PhET has interactive simulations, all sorts of math. This is kind of higher level. So those who are not scared of doing math and working on that, or if you're working online, these are beautiful. I'll give you a link. Okay. But to go along with our pizza, well, there's one for equivalent fractions, but if you just want to look at fractions, right? You just want to have some, you're looking at fractions. You look at fractions like this. I actually prefer the cake. Here's one cake. That's what half a cake is, right? One third of the cake would say. This is what 2 thirds of the cake would say. Right? There's a million of these. That does an amazing job. Equivalent fractions, graphing a line, ratios. They have it for everything, right? Not everything. I was trying to find one for these 10 million. Okay. Any questions about this? There's so many of them. Play around. I send it to them and I just say, play with this, just touch the buttons, you can't break it, right? What would happen? Nothing, really good, probably no. But I do give an option. I think really high level students and really low level students are more able to do it. The ones in the middle, they're sort of getting along without doing too much work and they can see the progress. They're not as apt to do it, but it doesn't matter. You're giving them the option. Okay. So multiple representations, anything that you can bring to a classroom that isn't numbers on the page, just do it. Once in a while, even. Key math, this is where we get into actual key math. Okay. When I say we're about to do math, how many of you get scared? Especially after getting to know me. Scary, isn't it? I know, it's not gonna be scary, I promise. Okay, we're gonna do some math. We need something to write on. And something to write with. And this is something I would do. I have pencils, and I have 3 types of pencils. You can choose which one you want. Some people like graph papers. I know a lot of people graph papers. Okay, I'm gonna get one. Anyone want line? You want a piece of blank paper that has something random on the back? Anybody else? If you want a pencil, you need to pen on the back. Okay, cool. Okay, so we're just gonna talk about adding, subtracting, multiplying, and dividing. I'm gonna give you a minute. I'm gonna give you some water. And I just want you guys to think about that. What does that mean to you? Words, scenarios, pictures, adding, subtracting, multiplying, dividing. Take some notes, or you can do, this is my notes suggestion for you. If you have an extra paper, this is what we're gonna do. We're gonna use this. Is this on the screen? Yeah, or no?
No.
How do I share screen? I guess this is the one thing I just didn't really, I've never taught my spot before.
Can you escape out of that?
I'm sorry, what?
Can you get back to your other screen?
I can get back to it. Oh, I can use the Zoom. Why don't I use the Zoom? I'll use the Zoom.
Okay, there you go. Yep, that works.
If we were doing this in my class, we would have known maybe that I wouldn't come out so hard if we do this. If we do, I know. It's a hard thing. Yeah. Students equally want you to be, they equally need you to give them time and the mic and have their input, but they really want to feel like an expert. They really want you to feel like an expert. That's a hard thing. Okay. What do you guys think about that? What could you say about adding? Making more of something. Making more of something. You said that. There's something making more. I'm just gonna put making more. And do that. Making more.
Combining.
Combine.
Easy.
What is it?
Easy.
Easy. Easy. Analysis.
Check with subtraction. Check your answer with subtraction.
Oh, I love that. We've never even heard that one before. So that's easy. I love that. Do you have anything from people that aren't here?
Oh, nope.
Nope. Okay, if you're in the, at home, you can chat, we'll put it up here. Anything else, anything else, anything else? Transparent. Transparent. One classic thing they talk about so much in class. I cannot spell, I can't pronounce them. It's okay. we can't-
Counting.
What?
Counting.
Counting. Love that. What is an answer to problem? You're looking at a set of problems, how we can know is addition.
Plus.
Plus, yeah. Equal.
How about a picture?
I do. 4 boxes.
So the adding is okay. So I'm going to say. I'm gonna actually do the 5. What about subtracting?
Going backwards. Taking away.
Taking away. What else? Deleting. Digital literacy.
Xing out.
Xing out. Sort of a kinetic thing. What was the question I asked you last time?
Difference.
The answer to a subtraction problem is called the difference. And that's an interesting word. Because it really speaks to something that we haven't got to on this. Right, the difference, right? You're talking about something, you have something and it's different to something else, right? The difference, yeah. Subtraction sign. Great. Thank you. You know, absent-mindedness is thing. Okay. So difference, subtraction sign, but when you say something the same, something different, what are we doing? Comparing. Comparing. There's some words for that. Anyone know what those words are? We're talking about subtraction. Then. Just something to remember. John. If I was to go and move forward with the same type of pictures, if we started out with these, and then we put in this Xing out. Okay. A little bit more intense ones. Multiplying.
Make it large a greater portion.
Okay, that's a great answer. Making.
Large.
Yeah.
A greater portion.
Yeah.
Repeated
I'm
addition.
going to caveat here. Because this is one of the things that we were doing for a couple of days. Yeah.
From the Zoom gallery, repeated addition.
Love them. Okay, I'm gonna put this right here.
Repeated addition. Yeah.
And then repeated addition. Okay.
Adding groups.
Adding groups, is that you said? I almost want to put parentheses, repeatedly. Okay, there's two questions I always ask. The times,
Multiple times, sorry.
yeah, time sign, but also the verb times, right?
Phosphorus.
I think it's the asterisk.
Yeah, like, oh, it's the asterisks are, you could do a dot. Asterisks are often used for exponents on the field keys. You can't get a superscript, so I think there's a good one, but that dot's good.
Product.
Products. Product is an answer to a multiplication thing. I should be, I'm so sorry. License students really. Nothing, anyone else wants something. Right, I would. Okay. Product. I'm gonna truncate this a little bit, but yes, times product of key addition. I'm gonna add something that's incredibly important for multiplication that you probably don't hear very often. That's going to take care of this. And the word that's almost the most important word for multiplication is called scaling. It's kind of a new math thing. And I'll talk about that during, this is when you take this on, what we'll be taking on, because you guys won't be on this whole journey with me, is we'll be taking on multiplying by a fraction and multiplying by a negative. Okay, because that's really about scaling, because at that point, we're no longer getting. Okay. Okay, what about
Break into pieces.
I'm sorry,
Break into pieces.
break into pieces. Love that. Okay, break into pieces.
Make equally smaller.
I would almost say that we could combine.
I
those.
guess that's the opposite of multiplication.
So I'm gonna change that word.
Okay.
What's good? Making equally smaller. And the reason I'm gonna say that is because in math, words are very specific. Opposite means the distance from zero. And what you're saying is inverse.
Okay.
Separate groups.
Separate groups. Okay, what are the two things that I'm gonna ask you about?
Make equal sets.
Make equal sets, these are great. These are, you really capture the things that sometimes takes a little while, which in the word equal is very important.
Division style.
Oh, yeah, so there's this symbol. And the other symbol. This symbol,
Quotient.
and what?
Quotient.
Quotient, yes, that's the word that most, it's hard one to get to, but
Oh, quotient, yeah.
this is the answer to division problem. Okay, so what we just did is really easy to do, really, actually. Meaning you're gonna ask your student what they think and you're gonna record it, you're gonna organize it for them, modeling good mathematical behavior. You're going to be honoring that process and you're gonna be learning lots of things about them, doing informal assessment. You're gonna add some stuff when you need to. Don't worry about the fact that you can put opposite if you want to worry about it. I just can't do that. That's my whole robotic way of thinking. Can't do it. That's just me. But what you did is you just started out your student on a road to them. And how much easier is it going to be for your student to look at this once you've done that? Oh, can you what? You want me to put it up somewhere?
Just hold it to the camera.
You can also send this.
Below it.
Where is the camera? They can't see it. You can send this to them in the list.
Okay, what's the name of it?
Called mathematical words. Maybe down towards the bottom. I'm guessing it's number 9.
Okay.
Okay. So you've just gone through this process. You've taught them. You now can show this to them and their brain has been completely opened up to this concept without you having to actually know anything about math or know this thing, but you have this tucked away, you looked at it the time before, and now you've just given meaning to that process. And then you keep this going because if we had more time, we would go and we would go over some problems. One that's adding, dividing, multiplying, subtracting. I wouldn't say that, obviously. We would pick out how they would know that. We would highlight the words and would show them that those were those things, and they would add it to their list. We'll talk a lot about units, more so than anybody would want to hear. And but we would also talk about the word each. We add that to multiplication division. It's very, very important. And the reason that that each is important is because it symbolizes the thing you guys already got to, which is the most important thing when you're talking about difference between multiplication, division, and subtraction and addition, is that they're all very related. There is a pair. Plus and minus are inverses. They undo each other. We want to do that. We do that through fact family. And then multiplication and division is also related. But what makes it different is what you guys already come up with. Multiplication, addition, subtraction always have to have units. You have 5 oak trees. We have 7 more oak trees. Here, you have 30 students in a class, but you're forming study groups. 2 different units. Oops.
Nope.
Here, there are 5 rulers in the door. You take out 2 rulers. Same rule. Here, you have calories and candy bars. So differences. The other thing is the word each. Because of what you guys said. Multiplication addition is in groups, and addition subtraction is not. That's the main difference. And if we can convey that to your students, you've built a foundation for all the word problems they're going to see that have to do with this. Okay. Any questions? Sorry, you mentioned that. Is it too much?
I think it's wonderful. What I keep coming back to is the interaction between what you're saying and trauma. So I have students who are sort of, I'm here for the GED, and so they just stare, why do you need, what is adding? And they just stare at you like, that's not what I came here for. They want the list. So I think the challenge is how to get to what you're talking about when they are like, okay, you need to tell me how to do this.
So if I was working on student 101 and they said, I just want you to tell me how to add, then I would just do that.
Mhm.
And then when they couldn't do it, if that came up, then I would build this stuff. But if they can.
Yeah, that's what I end up, yeah, you're right. Because I go, okay, take out your index card. This is how you add fractions. And then we get later and you're right. I'm like, well, you can't fill in the blanks. You gotta figure it.
Yeah. And then you start talking about, and then you don't even have to talk about trauma if you want to, but there's.
Oh, no, they talk about it.
Well, they talk about it, absolutely. I have like a million different ways in which I can, so one of the things that I add in is reading. So I have a lot of reading resources, so I can just do that. Let's just read right now for a second.
Let's take a
Let's
break.
just- Yeah, and research, this is wild, totally free. You control your breathing, the person next to you is naturally breathing, you and you're saying things. Right? 4, 7, 8, the 4s, right? 4, 4, 4. These are all things, and again, a million resources on them. You just start breathing, and you will start breathing with you. that they'll come to you eventually, you know. Any other questions? I mean, that's really what it comes, you don't have to, I'm not here to tell people what to. Definitely not what to do. They can go build some. Okay, well, should I start moving? It's a lot, it's a lot. I'm here, I love talking about math. Whenever you come to that place that you're a student, you don't have to take these if you don't want to. Here is a beautiful article, research article out of Australia about trauma. There's a woman who's in her PhD and she's talking about the very small ESL classroom in Australia. And it's a research, very fact-based, but also beautiful qualitative research. You know what this?
Yeah.
Okay, it's such a great story, and I actually put the last line, which you can read if you want to, sorry, that reference page, in the.
Okay, great. Well, I hope you enjoyed your your 2 sessions that you were able to attend today. We're going to have some quick closing remarks, and then I've got a few just really short announcements before we all sign off. So I would like to introduce Steve Sokolowski, our president of the board. So Steve, can you